at Lifeonic. As you can see, they have a phenomenal space here. So thank you guys so much for hosting us. And I will say, just to go ahead and get out of the way, under my tenure as only sole organizer, this is the most people at a meetup ever. So you guys get that's great. Yeah. Good job. So everyone trying to topple that immediately. Yeah, and then for the pizza and the sodas, and most importantly, the double pipe brownies. Greg from the Slack group back there, looking out for everyone. So we do have a website. It's still trydevops.com. It does have our code of conduct on it that we take very seriously. And we are still looking to change the logo so that we can do, can do stickers and all that kind of stuff, have those printed. Yeah, so check the website out. Definitely read through the code of conduct. And additionally it has links to Instagram, Facebook, all the socials things. Anyone hiring? Yes.
Yep. My name is Josh Wyatt. I'm the Director of Global DevOps for SolarWinds. I have 2 open positions. I have an AWS engineer position open within the Global DevOps team, and I also have a Senior DevOps engineer position, formerly known as Chris Short, who left us for Detroit, but I'm backfilling his role as well. So if anyone has any interest in that, I'll be very happy to talk to you, buy you beers, whatever, talk to you about the roles. So very happy to talk to you about that. Just find me whenever. Yeah, thank you.
Anyone else? Yep.
Yeah, so I say it every time, I'm always hiring. You can see we have tons of space. This is where you'd be working. If you like, you can pick out your office while you're here. We're looking for almost every type of developer because we're so new. We're trying to build so much stuff. So UI, like UI, we got that job. We got server side, DevOps focused, not DevOps focused, security focused, not security focused. Whatever you're into. Well, so he's a security lead. He says everyone's security focused, but you know, sure.
Who else?
I'm Avi. I'm the AWS DevOps engineer at HubScope, and we are hiring a AWS Java DevOps, something like that. So AWS guy, Java. So I can recommend you if you want,
and last but not least, Align Technology is hiring senior DevOps people on our IT side of the house, and we do run Docker in production. So, who is looking for a job? Anyone? Just you.
Yeah, just me. I'm a senior level DevOps engineer. I've been in IT for about 26 years. I have a depth and width of IT operations and development. I've actually done development. I've worked with Java environments, but not in the development side. I've done more operations side with DevOps, Java. I have a strong background in Atlassian toolchain, as well as several other tools that are open source, like SonarQube and several other technologies. And I am actively looking and interviewing.
Excellent. Any first timers? Well, welcome. Continue to come back so that we can again beat this current record. Yep, and we do it every month. So keep an eye on the meetup site. I'll be scheduling the next one within the next week or so for next month. Any other announcements?
My name is James. I'm a senior software engineer with Red Hat. I'm also the co-organizer for the Raleigh Puppet user group. So if anyone in your organizations or if you know anyone using Puppet, then tell them to come in and check out our meetup. We meet monthly. We alternate between Cary and downtown Raleigh at Red Hat. Next month, Monday, July 10th, is downtown at Red Hat. We'll be talking about Puppet, specifically around the performance project. And I think it's Foreman's birthday, July 13th. So yeah.
Awesome, cool. Any other announcements? All right, excellent. So so our speaker tonight is Chris Collins from the Duke University Office of Information Technology. Holy cow. The Duke OIT, and he's going to be talking about containerization. Take it away.
Hi, thanks for having me. As I said, I'm Chris Collins. I work for Duke's Central IT Department, and I've been doing container stuff for them for about 3 years now. I just want to give you guys, I guess, a brief history of our container journey, kind of where we started 3 years ago, what we're doing now with our platform and how we're managing the containers, and just a short look at probably what I think we're going to be doing in the next couple of years. So without further ado. All right, so this story starts a long time ago, and actually starts like 3 years ago in a data center just ways down the road. Right, and y'all know where this is going. Containers, right? So this started when I was the web hosting tech lead for OIT, and the web hosting architecture lead, I guess, for lack of a better word. And I was in a technical advisory committee presenting a plan that I had to try to recover from some virtual machines for all problems that we had. I was going to have this fancy, way of setting up PHP FPM and pods and reverse proxies and all this stuff, because our environment has sort of gotten untenable for us. We had 3 guys on the web team. The Linux team itself was a group of 9 people. The web team just specifically was managing 350 or 400 servers. Because every customer we had, their sites had to be kind of segregated onto their own servers because they were running WordPress or Drupal, and they get hacked and other sites would be compromised, and we were having trouble kind of just keeping up with that and keeping up with general maintenance anyway, right? So went to the technical advisory group and gave them a huge presentation, all the work that I've been doing for months, and then somebody was like, have you heard of this thing called Docker? Like, it's been in the news just recently. And it's like, no, I haven't. I'll go home and take a look at that. I was a little, frustrated. I was like, did all this work, right? Like, what are you doing? When that night I installed Docker, and I got the first container running on my laptop, and I ran a command inside the container, and like my mind was just blown. I was like, oh my goodness, this is the coolest thing ever. So I really have to thank those guys, because that was the day, like that minute, that my career completely changed. And even though I was the web hosting tech lead for the next 2 years, I didn't actually do anything else except containers for the next 2 years. They just kind of ran their own thing, and I went off on my own with the blessing of my boss, right? So that was how containers just generally got started within my team, and sort of for the larger department that we were working on, because I had kind of some leeway to play with it, right? So really quickly, why did we start looking at the containers? We mentioned the virtual machine sprawl, right? So that outside of the web hosting team, this was happening to the Linux team as well. Every service had to be segregated from other services because we had a wide customer base, and each of the customers were sort of responsible for aspects of the maintenance of that service. So we had to segregate it out so they wouldn't impact each other when there were problems, right? We were also trying to look at what none of us had actually heard of as continuous integration, but we were starting to think about that in those lines. A good example was our identity management group had these Kerberos KDCs that had to be up all the time, and when there was an outage, it impacted the entire university. And these servers were up all the time, and patching was extremely difficult. And when they made a patch that may break one bit or another, it was a widespread outage. And they didn't have a real good way of testing these patches ahead of time, and they had to apply the CVEs as they got security vulnerabilities. So they started looking at Docker and Jenkins as a way to, they containerize the KDCs and the containers, and they would use Jenkins to rebuild those every 4 hours and apply all the patches that were available, and then run through a suite of tests to make sure that whatever was in that image had passed those tests. So maybe they didn't redeploy that image immediately, but when there was a vulnerability that was released, they could say, okay, we have an image from 3.5 hours ago that passed all the tests and has the patch. Let's push that out. And they knew that it would work, as opposed to trying to, patch the box live and having trouble with it and roll it back, and just, an outage that impacted thousands and thousands of people. And then if you've ever tried to do a Google search for an image that would represent reproducible research, you'll notice it's pretty difficult for me, right? So there's a big component to research at Duke University. It's a large focus of the university in general. And one of the big things is being able to build an environment to do calculations and to do research, and then take that and give it to other researchers who can reproduce it the same way, right? And that's really easy if you give them a set of like equations on a piece of paper, but it's not so easy when you compile against like this Python library with this version of this development package on this version of Red Hat. And you take that from Duke and you hand the paper over to Stanford, who's using Debian with a different version of Python, and their package isn't the same version, and they can't get they run the same thing, and either the environment doesn't work or they get a different output. And that's a huge problem for the researchers. So they immediately, the research computing folks dove right into using the kind of image format that comes with these containers. And we're able to, they like the ability to reproduce that environment, not only in the Docker file that they can hand to Stanford and let them build, but they can also hand them the actual image that was used to run the container. They can hand them the actual container that ran with the results. And then just as for good measure, they handed them all that stuff and the data and the virtual machine VMDK that it ran in, just to make sure that it was all the same thing. And people at Stanford and elsewhere can reproduce that environment almost perfectly. So that was a big win for them. And it was sort of why they really got into containers ahead of time. And I don't want to undersell just quite how much of a push the research community at Duke gave us into this. Like, they're a major reason that we spent any time looking at containers, changing from our status quo, right? So those were kind of the three main reasons we got started. But at that time, it was still kind of a fringe thing that some of us were working on. We had a small Docker users group, and we get together and talk about what this thing is and like how does this actually work with the same kernel, and there's got to be a way to get out of these containers. They're not really secure, and you can't really run them everywhere. Just that kind of general discussion, and we were kind of playing around with them, sort of in halfway production, not really. But we ended up with a couple of quick wins that really solidified containers as a possible way of going forward in the future. One of them was during a denial of service attack, we had a really hard time just keeping our main page up. And I had been playing with Docker for a couple of weeks and was like, I think I can containerize the stuff that goes into our main website. And we can, deploy that on some servers out in AWS, because I should just be able to build the image here and move it out there and it'll work. So what do you say? And our bosses were like, we don't have any other solution at the moment. Go ahead and give it a try. We'll see what happens. And it worked great. It was up. Everything was deployed. It took 25 minutes from start to finish for me to create the image, create the Amazon Web Services account, create the server from the AMI, and deploy the service out to AWS. And we had never done production containers at that point. We had never done anything with Amazon Web Services. It was just start to finish, 25, 30 minutes, right? So that was a huge win. We also have an architect who is running thousands of containers in Azure to support a MOOC, a massive online something course, right? So it's running thousands of containers with Jupyter notebooks, so thousands of people can learn how to do database, interact with relational databases and stuff. And it's for students from all over the world. And we would not have been able to scale anything within our data center to that level in the speed of time that was required for us to spin this up for the MOOC. And it worked really well for him, and it was really easy. He developed a single image and deployed it. That single image is in use by all 84,000 of the, or 8,400 of those users. And that was an immediate win for both, again, the cloud services like Azure or AWS and containers. And then right away, the Jenkins and container patching for the Kerberos KDCs jumped right up there as something that was really great. And we were able to not only prove kind of the worth of containers, but of also what we ended up learning was continuous integration, continuous patching, and actually testing of the environment, making sure that things were built and tested fully in another place, right? And so it was a big win. These three things kind of really solidified that this was a way that we could move forward. Right. So we started looking at containers, and we're really we're putting them in real production. We're not just going to run these weird things in AWS and Azure. We're going to put some real containers in production on our environment, right? And immediately we ran into some little stumbling blocks because we were really trying to use containers in our traditional pet server environment, right? Little things that we ran over we never would have thought of, such as at the time, and maybe still, Puppet was hard-coded to find the network interface for the host, the primary network interface, alphabetically. Whichever one was the first one alphabetically was the network interface of the host, right? And you install Docker, and all of a sudden, Docker 0 is there, ahead of F0 or ENS, whatever. And so we've got half a dozen servers that all think that they belong to the 172 network that Docker sets up, and they start changing their configuration files and emailing and saying, hey, services are down, people can't talk to us, and it was not a good thing, right? But it was one tiny little thing that we dug into, and it was like just a hard-coded thing inside of Puppet, right? And it's because Puppet and Docker are really kind of clashing heads. They both expected to be able to do what they needed to do and not really deal with the other one. And that continued on for us, right? At the time, the Puppet IP tables module we were using, you put the rules in the IP tables module, and if the rule's not there in Puppet, it's going to take it out to make sure that it's, it's good, right? But Docker really heavily relies on IP tables rules to do all its natting and everything. So I spent an embarrassing amount of time staring at the terminal of my laptop like, why is this container not talking to anything else? And it took me forever to realize, like, it would come up and it would work and it'd go away, and oh, that was Puppet running and removing all the IP tables rules that Docker had put in when it started, right? And Docker doesn't like that. Docker's like, yeah, just don't talk to me anymore. I'm done. I'm done, right? They really expect to be able to control that stuff themselves, right? Both of them. So we really started having to look at how to separate that environment. And it's not really going to work on the full-fledged pet servers that we were setting up. They're sort of cattle, because we had Puppet managing them, but they're all individually configured. So they're still very much toward the pet environment, right? When you think about the pet versus cattle model. And then we also had just stumbling blocks that had to do with early adoption. We got into Docker when it was first really being talked about. And we ran into things like the fact that an early version of Golang had a hard-coded limit of 10 for the amount of times it would take a SIG pipe before it just died, right? And why is that really important? Well, what if you decide that you're going to change your journaling system to write persistent journals because you had been writing just journals into the temp FS and using Splunk to get it all out, but you want to look at it on your system, when you logged into the system, right? Well, you take that, you can make that change, you put it in Puppet, you push it out, Puppet reloads journal D, right? When Puppet reloads journal D, the socket that systemd had connected to standard out, standard error for Docker goes away. And when Docker writes to standard out or standard error, it gets a SIG pipe, right? So we pushed out this Puppet configuration across our entire environment. And then randomly, depending on how many times something tried to talk to Docker on the command line or through the API, you could get through 10 times and then the daemon would just completely die. So just imagine the day and a half or so of just like servers with Docker just like falling over, hour a piece, falling over, hour a piece, falling over. It was just ridiculous, right? And it sort of set us up for another realization that was a little more positive, I think. We started Googling like what we were seeing and how it was working. And we found a thread where somebody had already discovered this. They posted it to the Docker issues page. Somebody at Red Hat had figured it out. They posted it to Bugzilla. They figured out what the issue was, why it was happening, made a patch, posted it back to Docker, and it was in the next version. So all we had to do was roll back one version, wait for it, and post it back, or move to the next version. Yeah.
I'm not Docker in production, but one of the beauties of Docker is supposedly its read-only nature, and the fallover time is almost instantaneous. So you looked at the fallover as being a problem, but did you not take advantage of the fact that when Docker falls over, it should recover almost instantaneously?
The way that this was manifesting for us anyway was that it would fall over and the service would restart, and the containers at the time I were set to restart, but there was, I don't recall what the specific issue was, but there was something that was preventing the services from starting.
It did not fall over. It basically died and then
recovered. So I'm not talking about the containers that died or the services in the containers that died. I'm talking about like the Docker daemon on the host, like completely fell over because SIGPipe, in Go in that version 1.5 or whatever the Docker was written in, it hit 10 SIGPipes and then that was it. It went to bed.
This is Docker in production.
Yes. Yeah. Early Docker. That was fixed in the very next version of Golang and a later version of Docker. No big deal. But yeah, so that set the stage for something that is actually positive. Almost every time that we find a problem with Docker and we go and find it online, somebody from like Red Hat or Docker has already found it, already submitted a patch, and it's in the version that's coming down the pipe the next time we look at it. So the rapid development and just the care that people are giving to it has made it worthwhile doing this, even though we run into these kind of problems. Like everything's fixed quickly. And they've, especially the Red Hat packages that we're getting, they've committed to a release schedule that's completely faster than anything they had done in other situations, in our experience anyway. So it was totally worthwhile for us to go through this somewhat rocky production service because there was that kind of support behind it. Right? So yeah, this is the actual thing in question. That number 10 right there, that's the problem. Right? This is clever. We'll just handle it 10 times, and then we're not handling it anymore. Right. So we had another issue with early adoption. You may have heard that on operating systems that don't use AFS or don't support it, friends don't let friends use the device mapper loopback in production because of performance problems, right? And the general advice from Docker and Red Hat and all the other folks is to use an LVM thin pool and store your Docker data in the LVM thin pool because the performance is much better, right? And that's great. And you know, the folks at Project Atomic, I think it was Project Atomic, released a helper unit file for Docker called Docker Storage Setup that runs every time that Docker starts up to go ahead and check your available space. And if there's available space, it tries to configure your thin pool based on some parameters that you may have given it in the configuration file, and then make sure that thin pool is there and available so you don't have to go through all the fiddly bits of making a thin pool, right? Well, that service, you know, being as helpful as it is, runs every time Docker starts or restarts, right? And it takes a look at the thin pool and writes out some stuff. So what it ended up happening was it would make our Etsy LVM archive directory look like this. It would save those little metadata bits of information as a backup of what happened during that change to the LVM in the Etsy LVM archive. And it's filled up with thousands and thousands of tiny little files, right? And that manifested for us as Docker starting and restarting slower and slower and slower until it was immediately apparent that it was like 30 seconds for this thing to stop and restart. And it took us forever to figure out that it wasn't like the signal handling within Bash inside of a container and timeout things for Docker. But we ended up easily fixing that by turning off the Etsy LVM archive stuff, because that makes a big deal when you're running a server that's managed by a single sysadmin or a couple of sysadmins, and you need to add space and you add a disk and you expand the LVM, and it's probably a good thing to know like what exactly happened, how do you roll it back, how do you make that change if you need to. But if something like an automated script is running this thousands and thousands of times a day, it's probably not super useful to keep any of this information, right? And then this is Docker on these servers that are not really supposed to be pet servers, so the systems don't really deal with them manually anyway. So there's no real need for us to keep this information, right? But this is one of those stumbling blocks that you run over early when you're dealing with something that you've never tried before, other people haven't really done a whole lot with, and maybe this is the first time somebody saw it or something. Yeah. Right, so that's what happened to Docker with that as well, right? So eventually we realized that Docker was great and we're going to continue to get into it, but the time scale that the containers lived in was completely different than the time scale of anything else that we were doing, right? The containers would start and they would stop and they'd move around and they'd recover from things and they'd be deployed by folks. You could even look at your laptop and tell it to do something, and the containers would start and stop before you had a chance to check the output of what happened, right? So their time scale is incredibly faster than our normal services. And it's faster than the automated or the manual monitoring that we were doing at the time, where we'd set up a service and submit a ticket, and then a couple of days later it'd be monitored by the monitoring team. We'd set up a service and ask for backups to be enabled, and a couple of days later the backup guys would get to it, and a couple of days later the inventory guys would notice that there was a new server because of the change requests and stuff. And we ended up looking like this, right, trying to keep up with those containers, the services moving around. There were times that we created containers for development and testing where the container was created, it was started, it was deployed, it ran its entire life, and it was destroyed before that ticket had ever been opened by any humans ever, right? So that was something that we really just had to start to address, is the time scale for containers, right? And containers in automation are this guy. They're like flying flat out, but humans are this guy, right? And I mean, maybe going backwards. And this particular guy looks like he wouldn't like automation even if it was automating a strawberry into his mouth for dinner. Not to say that the humans that are involved are like that. They're super friendly and helpful, but they just can't keep up with the cheetah of automation and containers, right? So that was our first kind of forays into Docker, the initial assumptions and why we started doing it. This is where we are now, right?
A quick question.
Yeah.
Do you run Docker on the virtual machine or physical environment?
Virtual machines.
Okay.
Yeah.
So first you run your web app in a virtual environment, then you put your web app into Docker as is.
Right.
Was there any performance difference in the web app once you moved to the Docker environment?
Nothing that we could appreciably detect. I spent a summer even just doing straight up performance differences inside of containers and outside of containers on bare metal and on virtual machines. And aside from an issue that we figured out might have something to do with the way the VMware handles low power situations, there was no real appreciable difference in performance. So that was in the test environment, and in the real world, we've seen sort of the same things. Yeah.
I just want to throw out, I don't really have much of an explanation for this. We run Docker on AWS. We switched over to Docker about 6 months ago, and we got a 20% response time improvement getting off AWS into Docker. And I think AWS shares hosts with other machines. Could be something to do with that. One of them will make sure Docker and the scheduling and moving things around. I don't really know, but we did see some interesting things.
Yeah, it's good to hear.
Yeah, the real thing to remember with Docker is, in the end, it's still just a Linux process, right? So it should be no different.
No, I'm just wondering because they say another layer, it's a middle layer. Container itself is a layer that we need to deal.
I wouldn't really think of it as a layer so much as just kind of a process that's running over here. Like it's, I don't know if that's what you would think of it. Like,
yeah.
I don't think of it as another virtual machine or another hypervisor. It's just the same thing that would be running on your host, segregated away from everything else that's running on that host.
Just think of it as app separation.
Yeah.
It separates your apps from each other so they can't even see each other.
Yeah. Yeah.
So we've gone through a bunch of things that, of course, you ran into stumbling blocks.
Yeah.
And you put this through. Have you seen or have you written or anything, like a checklist or a how-to for like, you're going to document, you want to do this, you want to turn this off, you want to enable this, you want to.
I haven't seen anything like a definitive list anywhere. It's sort of been a collection of things as people have discovered really what to do. That would probably be something that would be useful for folks. I have like randomly posted things on Google Plus or my own website about like things that we have done because of this or that or problems we've run into and why. That's a good suggestion. I may go back and write something up about that. So, right. So keeping in mind what we just ended with the monitoring and the trending and the backups and the tickets and everything not being able to keep up. This was sort of what had to happen, right? This Docker is going to change everything. We just have to change literally everything about what we do, right? This was the quote, the best quote ever. And unfortunately, that was me. And looking back at myself 2 years later, like, oh, I can't believe I used that as a selling point for people. Like, of course, people were going to drag their feet a little bit, right? Really, for real. Right. So where are we now? We did change a whole bunch of stuff. We're using Atomic hosts. We're actually using RHEL Atomic, but it comes from the upstream project Atomic. There's nothing actually wrong with Atomic. I just really like that joke. The Atomic hosts are designed to really follow the Unix philosophy of do one thing and do it well. They run containers and they run it really well. And they're kind of slimmed down versions of a RHEL 7 host or a CentOS host or a Fedora host with a small number of packages, and they use the RPM OS tree technology. So they have their packages in a tree, basically, in their file system, and when you patch them, it downloads the changes in another tree, and you reboot and swap into that tree, right? So that's the Atomic bit, right? There's not a point when you're patching where one package is half patched, or one package is patched and another one's not patched. You swap right over into the next tree. But Atomic is great for containers, and that's what it focuses on. All it's for really is running containers. That's the whole purpose of the Atomic operating system, I think, in my opinion.
Have you looked at Rancher OS?
I've looked at it a little bit. We haven't used it as a production
I was
service.
just curious if you had any input on it.
I don't have anything, no. Atomic, I think, is a lot like CoreOS, and people have heard about CoreOS a little more than they've heard about Atomic, I think. But we're using Atomic because of the RHEL base, and the Project Atomic stuff is really cool, right? Part of what Atomic is also an immutable file system, right? Or most of the file system is read-only, right? So you don't just randomly install a package. There's not really a way to install a package if it's not already built into the Atomic operating system. Is really not going to go on that box. Sort of. There are ways that they worked around it now to overlay an RPM on top of the file system, and when you patch the underlying file system and reboot, it takes the RPM that you've overlaid on top and moves it over to the other one. So you sort of can install it, but that's sort of discouraged, right? So where's all my stuff? Where am I going to put all the stuff? Like our environment is heavily dependent on SNMP for monitoring, but there's no SNMP installed in Atomic Host, right? And we're heavily dependent on collect-D for sending trending data out to our Graphite and Grafana, but there's none of that installed. Git's not installed in an Atomic Host, right? VMware tools or OpenVM tools is not installed in an Atomic Host. So you think that would limit some of the functionality? Well, the whole point is everything is in a container, right? And that's sort of the philosophy as it comes from the upstream project. It's the philosophy that comes from Red Hat and Fedora. And that's what we have followed as well. So we containerized our SNMP service, and we mounted the relevant files into the SNMP container so that it can get the metrics and respond to the SNMP queries from our monitoring team. We containerized our collect-D host and mounted the relevant parts of proc in there so we can get the data from the files in proc and send it out to our collect-D or Graphite hosts. The Red Hat folks have containerized OpenVM tools, believe it or not, like all the really low down stuff that it has to do. They built a system container and they give that away. So we can run OpenVM tools using systemd on the host, installing it with an Atomic command, but is running as a container on the host. It's not like just running like a real binary. It's inside the container, and it works great because it's another process, like you said, right? So there's a little bit of stuff you got to fiddle around with and kind of get used to, but it works great because everything's in containers, and that's what it does. It runs containers, and it runs Docker containers, and it runs run-C native containers, and there's support for Kubernetes built in, and it's a large part of the OpenShift infrastructure, right? When you're running, yes.
Does it support ECS?
I'm sorry?
Does it support Amazon's ECS?
Does Atomic support it? There are images for Amazon ECS. We're using those in, or I'm sorry. You started talking about the container service. No, I don't think it's this is the host operating system, not the container operating system. Does that make sense? Yeah.
It'll run on EC2, but
Right.
ECS is basically Amazon's version of running EC2 instances for you that have Docker installed, so they maintain the operating system for that one.
And we are using images of Atomic in EC2, but we're not using ECS. All right, so 1 year into running Atomic Host in production, our Etzel VM archive directory filled up and all the Docker daemon stuff fell over because we completely forgot that was a thing we had done in the Puppet environment, and we didn't move it to the Atomic environment or even think about it, right? So, yeah.
That's one of the things for your list that you're building for him.
Correct. If you switch operating systems, you still have to fix the bugs, right? All right, what else did we change? We changed our configuration management. For all of our Atomic hosts, we're using Ansible instead of Puppet. All of our regular RHEL 7 boxes, we're using Puppet. We're using Ansible instead of Puppet for the Atomic host because it's not really easy to install Puppet on an Atomic host. And the clientless Ansible model works great where we just connect to the host and configure it. The Atomic hosts are also more about configure it up front, and there's really less maintenance overall ongoing, whereas, traditional Puppet environment that we're running, we use Puppet to maintain the state of the server ongoing. So that because the Atomic hosts are so slimmed down and there's very little to them other than the containers that are running there that are managed by the orchestration that's not even on that box, we don't have to really maintain the state the same way that we do with Puppet. So we started using Ansible for that bit and for provisioning and the initial setup, right?
Is Atomic host another Linux distro or something else?
The Atomic hosts are based off of the RHEL and CentOS and Fedora operating systems. So
It's still open source, I assume.
yeah. And if you did like a cat Etsy issue or whatever, you'd get the Red Hat 7.3 whatever from a Red Hat Atomic host, right? So
It's just customized for containers.
yeah, and the big thing is the RPM OS tree thing. So you can't just yum install anything. Like RPM is still there, but the whole OS tree is being managed by the RPM OS tree stuff.
Yeah, I think the website is it projectatomic.io.
That's right.
Yeah,
And
go
it's
there,
linked in here as
open
well.
source, you can just download it.
And there's a link on here too. So
So your architecture is immutable. What are you using as, what config are you managing?
So it's not entirely immutable. Most of the file system is read-only, but some of the configuration files are not, or the configuration files are not. We're using Ansible to set up the initial files for the LVM thin pool, so the Docker storage setup will expand that thin pool for us, right? And that's really just changing etc sysconfig docker-storage-setup file. And we're placing some certificates on the host so that we can talk to the Docker API using the certificate authentication, right? There's very little other setup. We're not creating users. We're not, we're obviously not installing anything. There's almost nothing going into this setup. We do expand the drive because we add another drive during provisioning to make sure that to get past like a smaller, by default, the image that we've got has a 5 GB size for the root partition. And we add a swap file, and that's it. That's all we do. And so, yeah, we've been using Ansible for that instead of Puppet because we don't need that full Puppet environment, right? And it's kind of a trend. Ansible actually worked out so well and was so easy to use that we've started doing the provisioning of our Puppet hosts. When they come straight off the automation bit, the thing that pops up and runs is Ansible to set up the bits that need to set up and then kick off Puppet so Puppet can manage it from then on. And if you listen for the rest of the presentation, you realize there's kind of a trend of stuff like that happening, and we'll come back to that a little bit later.
Yeah.
Right.
Is it part of the virtual goal to just rip up and go for Ansible?
I don't think so. And that's more of the Linux team's decision, but I don't really think that's what they're planning on doing. They're pretty well into using Puppet for a lot of their stuff. I would suspect if more and more, and as more and more stuff becomes containerized, that it'll become less and less important in that environment in general. But I'm sure there's a role for Puppet continuing going forward, definitely. Like they're solidly invested in Puppet. Okay. Right. Right. So outside of the actual like management of the hosts and things like that, we also are dealing with container orchestration, right? So for our container orchestration, we developed a Ruby on Rails application that I super creatively named Stevedore, right? It's great. If I could take that back, it'd be great because when you have a service called Stevedore, nobody knows really what that does, right? Especially customers who have no idea what a container is. Right. Manages Docker through the REST API on the hosts. It talks to the atomic hosts through the Docker API. It orchestrates containers across hundreds of those hosts, and it groups them into payloads. So there's service sets of containers that go together, like SQL and PHP and Apache, or those kind of things that you would expect to be grouped together as individual services and containers, but they come together as a package, right? People ask me why we didn't just use Kubernetes for this. And at the time, things that I read was like, Kubernetes is amazing. It's great. It's not quite production ready yet, or they're doing some really cool stuff. The next version is going to have everything that you need, but this version is still up in the air. So we were like, okay, well, that's no big deal. We don't need Kubernetes. We can just do it ourselves, right? You guys get the irony of that statement. None of our team took the time to sit and think that Kubernetes was made by Google, right? It was maintained by a community of thousands of people who are making patches all day long, every day. That maybe that would be better than building something from scratch maintained by 3 boneheads, right? Didn't even think about it, didn't cross our minds. Right. So basically what we did was we reinvented the wheel on our own in a Ruby application that's being maintained by 3 boneheads, right? So getting back to container orchestration, our application is not completely useless. It provides a web front end. Unprivileged users can log in. They can say, I want a particular service. We've templated these services. So they can say, I want a Drupal WordPress. And this can be a student that has no idea how programming or anything works. They just want a website. We can throw the code into an image, throw it up on the website, and you can have it. Our application also does SSL certificate signing through our CA with some other API automation. We do shibboleth registrations for identity management things. So it's not a complete waste. Yeah.
To be fair to your outlook, when you started, doing your own orchestration. And what has happened is that over those 2 years, Docker itself, API has evolved and its orchestration has become much easier, right?
I think so. When we first started, it was pretty difficult for us to get a set of containers running, and now it's not really difficult at all. Yeah.
So to the point where almost you start wondering, why am I buying into a Kubernetes infrastructure when Docker provides so much stuff?
Yeah.
Especially running swarms and.
Well, I'll touch on that in a second.
Okay.
So yeah. So our application, on top of doing the stuff of orchestration, also allows developers to scale things. They can go into a web interface, press a button, and that same payload can be deployed on another host, and we'll automatically set the CNAMEs up and load balancing, and it'll load balance across the host, right? And it gives them a web-based management interface to do all this stuff. So they don't have to log into the console, because our web developers don't like that. They like the GUI stuff. And I'm okay with that, and that's what we want to give them, right? And so into this process, we also introduced some built-in continuous integration, right? And this is sort of where I think a lot of this pays off for us in terms of development and process. We have all of our stuff that is deployed in this web application is deployed as a set of containers, and there's a set of rules for deploying those containers, right? We can take those rules and we can replicate that in Docker Compose. So every one of us can develop our applications locally on our laptops using the same images and the same containers with the same links and the same volume mounts and the same things passed into them. That is done in production, right? Better than that, because we're using a Docker Compose file, we can set up a pre-commit hook in our Git repos so that when we do a commit of the code, it fires off. It'll build those images for us with the code changes that we just tried to commit. Set them all up, start the stack, and then run through a series of tests that we've built into the image to make sure that they pass all the tests that we need inside that image, inside that stack, right? And it makes it really easy. We have the same commit hook that just says, fire off whatever is in the Docker Compose file, run this as the entry point, and if it fails anything, don't commit it, right? So if everybody's doing things that they should be doing, we don't actually have anything that fails a test get pushed into the code base at any point, right? Assuming people don't do things they shouldn't be doing, right? Right. And then, when we push the code up into the Git repository will use a webhook to talk to our orchestration tool, which notices now there's a change, and it talks to Jenkins and tells Jenkins to pull a code. Jenkins goes and pulls the code and builds that image on an atomic host that we've set aside for building, multiple atomic hosts that we've set aside for building those, and then fires up that stack and runs through that same set of tests just to make sure that the images it just built are the images that it needs, and will continue to pass the tests. That's important because we did at one point run into a situation where we built an image and it passed our tests and we pushed it out into production, and it went through the whole Jenkins build and everything, and that image was missing half of the file system, and we have no idea how that happened. We're never able to replicate it. And if we just hit the rebuild button in Jenkins, it rebuilt the image and it was fine. So at this point, we're committing tests or making tests locally to make sure that we're not committing bad code, but we're also testing the actual final image that's going to get pushed to the registry to make sure something weird didn't happen, right? It's supposed to be identical. What you run here is what you run there. That's not always the case, right? And then because this whole thing is automated, the whole build of the images and everything gets pushed to the registry, and then Jenkins notifies our orchestration tool that there's a new image ready to go. It pulls down the image onto the atomic hosts where the payloads are running that use that image. It creates containers for that stack from those images, stops the old container, starts the new container. So I can go from the very initial commit all the way out with no human interaction, right? And there's a spectrum there. Not everybody is doing this whole all the way, they just make a commit and that's it. Some people are still uncomfortable with doing that, and they can go all the way to the other end of the spectrum and press all the buttons to make sure that it rebuilds the image and redeploys the image after they checked it all out. And that's fine, because what we have seen is that as people do that manual bit and see over and over again these tests have done what they're supposed to be doing and the automation is doing what they're supposed to be doing, they slide down that spectrum toward the full automated deployments, right? and end up saving a lot of time. So my team has fully embraced it. We make a commit, run through the test locally on our laptop, and if it passes, we push it and we just move on, and it's in production in a couple of minutes, right? So our development in our containers matches the production in our containers, soup to nuts, beginning to end. Everything is identical as far as we can get it, right? So you might be thinking to yourself, we've got a web application that's managing the containers. We're using atomic hosts. We're using templated web services. There's a built-in Jenkins continuous integration, webhooks, Docker registry, migratable payloads. Why does that sound familiar? To be fair, at the time I didn't know OpenShift hadn't been doing containery stuff. It is now doing all containery stuff and is doing all the stuff I just talked about, and it's doing it better because it's a community, thousands of brilliant people maintaining patches regularly, and 3 boneheads are doing it on our side, right? So we sort of reinvented the wheel again, but it's no big deal. Like it's working well for us, and we've learned a bunch of stuff, and just kind of understanding how this goes together, I think was really valuable for our team. But we still have this moment here.
Yeah, but I mean, I would say in this case it's pre-invented, because I mean, I've done this a few times in my end. Like, I started writing object relational mapping type libraries before object relational mapping became a big deal, but it was like within like a year, it was a big deal. But I understood it.
Yeah.
And I think that's kind of the same thing with OpenShift. I played with OpenShift just literally like 8 months ago, and it just was very different than it is now. It didn't have this nice mini shift thing. It was, all the ideas were really sparsely documented and very segregated. It was very complex. It had a lot of work.
Well, I appreciate that very much. Thank you. Parallel development or parallel invention is a good way to make yourself feel better about doing something more poorly or not quite as good as the way the other guys do it, right?
Before you got on board with other products, how are you handling persistent storage?
That's an interesting question. We've gone through a couple of back and forths on what we were doing. Right now, we are using, well, within the very recent past, we were doing persistent storage by writing out volumes onto the disks of the atomic hosts and using the atomic host for persistent storage. I'll talk about that a little bit more in a minute.
Is this still on AWS?
No, none of this is in AWS. This is all in our own data centers. We have containers and stuff in AWS, or not, but not very many. And none of them are using, the ones that are in AWS are atomic hosts, but the stuff in Azure or like Ubuntu hosts being managed with like bash scripts and things because they're single containers and very easy to scale out, right? Yeah. So this is all a local data center or multiple data centers in Durham, right? So I met a guy in DevOps Days talk at Raleigh last year. And it was just one of those kind of ad hoc discussions where everybody kind of gets together and talk about the thing that they really wanted to talk about. And he was talking about how his company does this really great stuff where he will destroy, or some automated process will destroy a host, or it will drop a database, or it'll remove a route or something in AWS. And that was really interesting, and it's kind of the pie in the sky goal for us, and I really like that. But what I really came away from his discussion was this little nugget where he said that he explained that in their opinion, they created a host, like a server from a template, right? Not containers or anything, just a server from an AWS AMI, right? And after a sufficient amount of time, no matter what that server was doing, if it was in production or not, it was not the same server that they had set up from that AMI. It was not the server they knew when they met it, right? So they got rid of it, they dumped it, right? So they had a hard lifespan for these servers. They lived X amount of time and then they killed it and it was replaced with another server. And they had the automation set to kind of really be able to do that without any issue because they were doing all the cool chaos monkey stuff that we all heard of and really impressed by. But that was a nugget I took away from him. And I came back from that conference and just kind of ruminating on that thought. And within about 2 weeks, I decided that, well, that same thing needs to happen to containers, because how do we know if a container's been out for 2 months and hasn't been recycled yet, even though its image has been patched 12 times? Maybe it's still running a CVE or something because the developer hasn't made any changes and hasn't kicked off any code builds, right? How do we know that that container is what it's supposed to be? And we can't. if it's been X amount of time, that container is not the same container it was when it started. It may not be bad, but it's not trustworthy, really, right? So I wrote just a little, like one tiny little method to do Logan's run for containers, right? So every 7 days, our containers, if they're 7 days old, they get called the carousel method and they're killed. And there's no rebirth, nothing fancy like they talk about in Logan's run, right? And that's been successful for us. At this point, I could say with certainty right now, there are no containers that we're running in production on the atomic host in our data centers that are 7 days old or older. And on top of that, any containers that are deployed in a payload with that container that was 7 days old is killed as well. And the odds of those not being the same age are astronomically low. Like somebody would have had to really fool around and do some crazy things to get that to happen. But if it had happened, it would also be destroyed. And on top of that, if there are other payloads of the same type with the same code on different hosts, they're all destroyed every 7 days to make sure that we have the same code across all the payloads, right?
Is that based on the creation of the
Creation of the containers, yeah.
So you could have, it's not all of them at once, it would be
Oh, yeah.
scattered.
Well, right, but that's why we tie them all together, because they may not all have been created at the same time, because the image might have been the same, despite one being created one day and one being created the next day. Maybe the image hadn't been patched. But if the first one reaches 7 days, even if the other one had been created 3 days later from the same image, we kill it. It goes away as well. So we make sure they're all recycled every 7 days for that exact reason. Right? We don't want to stagger code bases even. Like we don't want the images, even if they're the identical images, we don't really want them to be staggered. Yeah.
Is there any downtime on that process once you keep all the containers?
Depends on the importance of the service. If it's like the random department's website and it's 3 o'clock in the morning, all this runs, late hours anyway. It might be down for 20 seconds or something after, the containers are torn down and the new ones are created. If it's a service that's load balanced, it tears them down serially so that they're all torn down within a minute or two, but none of them are down all at the same time.
So if you're running a cluster or a group of containers, that you'll cycle through them, but they're not all at once.
Right, they're not like all at the exact same second, but within a minute and a half, 2 minutes, they're all have been recycled. So I met that same guy, right? The same guy. A few weeks later, or I didn't meet him a few weeks later. He talked to me about that. I brought it home and killed the containers. A few weeks later, I was thinking about the atomic hosts because in the middle of the night, one of the atomic hosts had been patched and it went down for a reboot and it came back up. And one of the patches was SE-Linux. And when I rebooted SE-Linux, we applied all the labels and it took a little bit of time and it rolled past the window that we had allocated for patching. And it paged a sysadmin who got up at 3 o'clock in the morning to see that the box had indeed patched the way it's supposed to patch. It just took a little bit longer. And he showed up in my cube at 8 o'clock in the morning, grumpy. And I give that to him, like that sucked, right? And I started thinking, well, how are we going to figure out, like, how long is this going to take the patch? How do we set the patch window so that we know that it's still patching? Or maybe it's patching, don't page the sysadmin if it hasn't been like 3 hours. But what if it's been patched and it's still in 3-hour window and the service goes down? Like, how are we going to deal with that? And then I was like, why do I care, right? We're like patching these in a template every week, and the atomic hosts have nothing important on them, just like the containers have nothing important in them except for their persistent data, right? So we are writing a persistent data out to the atomic host, and the containers can just go away whenever. What if we put that persistent data somewhere else? Then the atomic hosts have literally nothing that's special about them, and they can go away whenever, right? So we're in the process of automating provisioning of NFS storage for persistent data. And what we're going to do is have our application mount NFS exports onto the atomic hosts whenever the payloads are deployed onto those hosts. And if they get moved, they get mounted somewhere else. And then we can just kill atomic hosts every 7 days. That's great because we've got some that were created, a year ago, and they still live because that service has been on there for a year because it's a long-running web service and it's doing great things and stuff. But it's not the same atomic host as it was when it was created. And indeed, it's not even the same atomic host created the same way as the current atomic host because we have a whole different Ansible setup now, and it's been applied to that host, but there's cruft, right? And we don't want cruft, especially with stuff like this, where you really want to treat it not even like cattle. Another quote from the DevOps days in Raleigh, somebody said there were pets, there were cattle, and then there were bots, right? And we really want to treat the containers and the atomic host as bots. Like, where you can really kill them and like light them on fire and like stomp on them and you not really feel bad about it the way you would with like ants, right? So far beyond the pet model, we're going to get into bots, just kill them, right? And so this opens up a lot of possibilities for us, right? If a sysadmin gets paged by a box, whether it's working now or not, kill it, take it out of the rotation, we don't care. If a sysadmin gets paged by the box, then it's fine. You know, it paged, something happened, kill it, take it out of the rotation, right? If a box needs to be patched, we're not going to patch the box, kill the box, take it out of the rotation, right? If a human being logs into the box, kill a box, right? Because the human could have done stuff. They probably know what they're doing because they're in the ops team and they know why these things are doing what they're doing. But a human's logged into the box. It's not the same box that it was. Why deal with that? Just kill it, right? So we got to the point where we're still working on this bit, but we're getting to the point where we don't really care why a box is not working, why it was paged, what happened to it, unless it happens 5 times to, you know, different sets of boxes. At that point, there's something really going on that we need to look at. But if it's just some random transient thing, and we all know what, like, that happens, right? Like, some box is just weird for a little bit because of something. We're not gonna take that chance. We're just kill it. We don't care. We really don't care. And we're not gonna spend the time or the salary of figuring out why this box was a little bit slow for the guy logging in from China last night at 4 o'clock in the morning when we can't reproduce it. If we could just say, okay, we'll kill it and we'll bring it back up. And if it happens again, more than once or twice, then we'll look at it and spend time. Yeah.
So restarting a container is relatively painless, but restarting or refreshing an atomic host to off-level software sounds like it's going to cost you a little bit of work.
There is work, but it's not work for humans. We have it. We just don't, it doesn't matter to us, right? Like, it's better for us to have the automation, build another atomic host, deploy some containers, and hit some APIs to point things to it, than it is for us to risk the fact that maybe this atomic host is okay. Maybe it's not, maybe it's been changed, maybe there's a bit out of place. Or
do you always have spare hardware to do this on, where you're recycling so many in a queue?
I think we are sort of lucky in that sense.
Okay.
We've got a relatively large budget for VMware. My department manages virtual machines for the entire university. So we have capacity. It's not always lots of capacity. It might be right there on the edge until we get the next shipment. But there's, especially since we're recycling this stuff, we bring one up and tear one down. As long as there's enough space to fit both of those at the same time, we're not really gaining or losing anything from, you know, the resource perspective.
Do you guys have public cloud conversations? And that seems to be the elephant in the room.
Yes, we have.
I'm sure everybody does.
It doesn't make sense for us yet. There's a graph like this, right, of the cost of how much it costs to be in the cloud, and it's coming down all the time, right? But we have giant data centers that are already there that are subsidized by huge amounts by our Duke Health, right? So they're paying huge amounts. So we don't have to pay rent. We own the buildings and the land. We don't have to pay for power because we got a power plant of our own, right? Like, none of that really factors into it. So for us right now, it's cost-wise, it does not make sense for us to pay for AWS for large amounts of deployments. Unless there's a process or a benefit in like performance, we're going to stick with the data centers for now.
I would say that's actually a trend, like at large scale.
Mm-hmm.
AWS can be as much as 9 times more expensive.
Yeah.
Than having your own data center. That's a large scale, right?
Yeah.
So we have a lot of processes where things go from engineering to production. We actually migrate them back into our own data centers.
Yeah.
For cost purposes.
Okay. Yeah. And I think that's probably true for a lot of people who don't have, or who have, you know, it's like you said, I had the same conversation with UNC, and it was exactly the same thing. They don't have to pay for any of that, so they don't go to the cloud.
What's your power plant? Is it coal based or?
It's when I started here, there was a giant coal pile across the street from one of our data centers. That pile is no longer there, and I don't think
gas.
There's coal. It is gas now. Yes, it's gas. But 10 years ago, there was a huge coal pile across the street next to the parking office where you went to get your parking pass.
You were serious about that.
It's serious, yeah. We got our own power plant. Yeah.
No, I mean, serious about the coal.
Oh, serious about the coal, yeah, definitely. There are train tracks that came and dumped the coal onto the ground across the street from the data center.
There were doctors that parked at Corvettes under this big wall with all these little pieces of coal and precariously perched. Thought you knew it was going to fall on that doctor.
But he had to park there to get his parking pass. Right.
I expected it more like somebody comes up with a match.
Yeah.
And it's like, there goes your data center.
Yeah, I don't know how coal really works, but that's probably pretty close, right?
Yeah.
Luckily, it was across the street.
Okay.
Right, so what's not in the setup that I just described? We have some identity management containers that are run for things like the Kerberos KDCs that are sort of sensitive and have sensitive information and sensitive data, and they don't necessarily want to be in the same setup as everybody else. So they have a single container running on a single server segregated for their services. Not all of it. They have definitely bought into the orchestrated stuff for their Ruby on Rails development because that's a great workflow and they're not dealing with that kind of data. But for the sensitive stuff, they're doing literally a single container on a single server, and that's fine. It makes sense for them, and I'm okay with that, right? We also have all those containers that are out in Azure and a handful in AWS that are generally single container course applications. They're easy to scale, single image. They're just kind of there for scale reasons, and they don't necessarily make sense to be in our environment, right? So how do we do things that we tried to do? Right now, how are we doing with reproducible research? Well, all the stuff that I talked about at the beginning, why they wanted to use reproducible research to be able to reproduce the environment exactly and send it out, like that's great, and people are using it and they like it, and it's taking off, right? In addition to that, they're also using images to build the tools they need outside of very protected networks where we store very important data that, you know, the Department of Justice would like to talk to us about if it gets out, right? Stays in there, but they, you know, traditionally they couldn't build their tool sets. They couldn't install packages or install their software. They're building those things in images outside and shipping them into the protected networks and running those images in there to do their number crunching and get the results back. That's been a huge deal, and the researchers that are involved in that really, really like that. And they're using Singularity containers of all things because it allows them, not of all things, it's a good service, it's a good thing. It allows them to run their containers without root privileges on those hosts. So the Linux team that's managing it doesn't have to give them full-on root permissions on the host that they're running their services on to be able to kick off their containers when they have data to do or to manage, because it's not a container that's long running like a web service. They need to run it right now, and it's going to be done, and it's going to go away. So they have to be able to do that. And Singularity was the way for us to do that without root privileges. Yeah.
Security and token encryption and all that, is that built into the file system? All that related to.
In terms of what bits?
Handling it, I mean, don't you have to use tokens, encrypted tokens, like
For
with different parts of the.
For the orchestration stuff, yeah. But the research stuff is even outside of that bit of orchestration. It's stuff that they're moving their images around using the tools that have been built to move data in securely through this network. It's not part of the. We don't have any ports open to our orchestration tool inside of these super protected networks because nothing gets in and nothing gets out unless they very specifically build an image and inspect it and it's looked at by, you know, security folks and everything, and then it comes in.
So I guess when you talk about data, so I guess you are doing on the medical research side now.
Yeah.
Okay. And so obviously it's all different clients.
That's the idea, yeah. Hope and so far that's how we understand it works. So.
Now, is this knowledge that you guys are doing widely distributed among researchers and the rest of OIT? Because I'm asking for a specific reason.
Sure.
My wife was doing a project. They were doing something, and they approached OIT, and they had no idea what she was talking about.
Yeah, it's OIT is a relatively large organization. We've got 300 something people, and there's a number of departments inside the department. whoever she talked to may not have known about this. There is not like, there's so much, we have so many different networks and subnets and infrastructure for storage and VMware and stuff. It's for any one person to really know about all of it is difficult. So there are people who probably know that we're using containers. They probably don't know about singularity containers, going into the protected networks and stuff. I don't know if you guys have heard Darren, and Darren have heard any more about that stuff than the other folks. Yeah, so I think there's a group of researchers that are working with some of the architects and the engineers. But the uptake is quick, like more and more people are hearing about it, but it's not something that's just like, here's a standard server so you can go press a button and we're going to build an image and ship it in for you. So.
Yeah, I mean, being in an academic environment as well, you would think that everybody would jump on board and want to share and talk about information. But you literally have like single person silos in every building. So
You should try the DOD.
Yeah,
Right.
it takes a lot to disseminate this stuff.
I used to work for a defense contractor.
I was working
not fun.
Cisco's DOD sibling.
Yeah.
So I applaud the, taking the inputs and the outputs of your containerized environment that's doing research and shutting them down.
Mhm.
But that implies there's a way to get the information that the researcher wants out. Is
Right.
it all a manual process, or is there an automatic process of getting the research out? Is there checks on what comes out when the researcher gets their data out?
I don't know enough about that environment.
Okay.
For that, yeah.
Something like pace.
Pace and PRDN, yeah.
Yeah, so, yeah, there is a very controlled process that involves humans that actually audits every piece of data going out. And so you don't get to get out your data unless you kind of submitted it for review by some group of humans to say, yes, this looks good, there's not any, protected health data or social security numbers.
Now, how do they do these privilege so that you don't have a super operator that is approving data going out?
We have a super operator.
Okay, so now don't you have the NSA problem of, and I listen to people who were in the military and they say, oh, yeah, I had super intelligence privilege. I was the guy who did IT for the military, and I would walk into any lab and fix their computer. And what was on the screen, I had to forget or shoot myself.
No, we're not really dealing with that kind of data.
Okay.
This is health data.
We're more dealing with, we're just trying to prevent a lot of the things that have happened to have been accidental. We're trying to manage accidents.
Okay, so you just want to be conscious of everything.
Yeah.
We're also trying to work on data integrity and the fact that there was a big problem with somebody doctoring it, and that ended up on 60 minutes. And it's a big problem that we're trying to do that, but that's a totally different process. So, and I would say most of the things that PACE is trying to do is prevent accidental disclosure.
All right, so I'm running out of time. Let me run through these real quick. I think we're at the end. I would say for continuous integration, we also had a pretty big win there. The adoption of the continuous integration from folks who hadn't been doing it to folks who are doing it now has really taken off, and they really like the automation that goes into all that bit, right?
Are you running Jenkins and containers?
Yes, we are running Jenkins and containers, and we're also using GitLab stuff for some of that. The virtual machine sprawl, did we solve that all down? We've got one sysadmin now. He runs 6 servers, and they do all the containers for us, right? No, not really. That actually was not quite the same way, right? Because some of that is really difficult to do all the port mappings and make sure that the ports are forwarded for reverse proxies and all the management there with stuff that we have written. There are better ways to do it. That's not, I think, and we're going to look at those, but that's not what we're doing now. So we still have about the same number of servers. However, in terms of, we talk about surface area as attack vectors, but in terms of surface areas for maintenance, these hosts are much smaller. So sysadmins spend much less time involved in those hosts. And they're all running containers anyway, and there's nothing special going on. So sysadmin time on the atomic host is way down. And then the atomic hosts themselves are slim, so we get more of them in our VMware infrastructure than we did with traditional Puppet hosts that spent, all this, the resources doing all the other stuff that traditional servers do, right? Side benefits, we did get, it's much easier to scale using computers and the atomic hosts. We can scale out the atomic hosts pretty much as far as we can, have a virtual machine space to scale out. And we can put containers on those atomic hosts at that same scale. As long as we can kind of load balance and make sure we got enough storage, everything works fine. Like it scales out. We haven't really hit a limit at this point, right? So that was a win. We also have rapidity or rapidness, or things are fast, right? So images build fast, development is fast, deployment is fast, recovering from problems is fast. It's completely different than it was in our other environment. And this is sort of how our environment looks now. We have about 1,500 containers in production on 150 atomic hosts. We have the traditional hosts that the IDM folks are doing, where there's one container per server. So if they have 71 containers, there'll be 71 servers. We have the cloud stuff with the Jupyter notebooks running the stuff with the MOOC. And we have other cloud stuff for coursework with RStudio that students can log into and use RStudio containerized through their browsers. So this is sort of a non-container things that changed. Remember when I said we had to change everything to do this cool thing? Well, this is all the stuff that changed, and this is the trend. Not only did we change all this stuff, it was already in the works anyway. We were already automating some things, but the container orchestration and the automation really go hand in hand. At this point, they're sort of inexorable. We can't really separate them out. And sort of like how NASA, made Tang, and now 7-year-olds can have Tang at breakfast. All the system administrators and the people who are doing things traditionally can use the automation that ended up being developed as part of dealing with the speed of the containers to their own advantage as well, right? Maybe let's see, yeah. So that quote still stands, right? It's not quite as embarrassing as we've gotten to that point, but ahead of time, it was just bad news. Don't say that to your system administrators or your developers, right? Right, so, and quickly, what about the future? We're gonna let somebody else do the orchestration. I think OpenShift is probably the way we're gonna go with that. It's gonna be the underlying bits. We're still gonna have our web application do some of the things and make it user-friendly for really non-technical people, but OpenShift is gonna do our orchestration. We're gonna look at different types of containers. Docker's doing some cool stuff. We've also got Singularity containers now. We're gonna look at the Run C and the OCI standard containers, and just try to offer as many options as we can to the developers and to the system administrators. And I think that the way that things are standardizing in the community now, that won't be a problem. And then finally, we're gonna really stop thinking about containers, because at this point, they're sort of a utility for us. We know they're there, we know how to build them, we know how to deploy them. People are learning about them, but they've got a life and they're gonna continue to grow on their own. And we're gonna focus more of our efforts on dealing with the orchestration, dealing with it, adding new services, and helping people to use those things. Users never see these containers. The system administrators don't ever log into the hosts. We don't really think about containers, or we're not going to. They're our commodity. You turn on the water and you expect it to be there. Containers are just another RPM in our tool chain or whatever. So,
do you use the public Docker repository idea where all your containers are pushed to, then that the system pulls them? My question is, if you do, is that like a choke point that gets full and you gotta thin it and clean it out and vacuum it and all of that stuff? Or?
We have several. We push them to our internal repositories. We at points have had to clean them out, but I think the way that the layers work, the actual incremental changes are small, and even though we're building images and pushing them over and over and over again,
yeah,
the things that actually get committed are tiny things.
So that hasn't become one of the things that always fills up on a Thursday afternoon and you gotta go clean it out.
No, and if it did, we would just sort of expand the space for now. It's not something that we're really concerned with trying to clean up. Yeah. At some point, we'll be able to identify, or we probably could identify all the orphaned images. There's thousands, like 90% of the storage is probably orphaned images because we've moved on. But it doesn't really matter. Like, we're running our registries in containers. We can just spin up another registry with a different storage and build some images for a day, and then swap everybody over to those, and all the old images are gone. We don't care.
Do you use public images?
We use public base images. In very few cases, we'll use a public image, get the Docker files and build them on our own with our own changes. We have totally blacklisted pulling directly from public repositories on our atomic hosts because we need to be able to control just kind of what goes in it and the patch levels.
And then did you measure uptime before and after containerizing Duke, and how much did it change?
I did not measure it. There's a metrics team that probably has some of that information. I would also say that we haven't, containerized Duke. We've containerized a small portion of Duke, but it's growing. It's at this point we've got just about half as many atomic hosts as the original web team that I was on was managing in VMs. And I think once we get kind of the workflow down with some of the web developers, most of the web team's VMs are just going to go away within just a few weeks, and all those will be deployed in containers. Individual uptime is, I don't have any. I couldn't even guess. It's probably similar, but I'm not sure.
How do you handle zombie containers that just have no life or use and they're still hanging around?
It depends on what you mean by zombie. If they're just containers that are there or were spun up and they're not being managed, we kill them. If they're containers that were spun up by somebody who has since just stopped caring about it and left or whatever.
That's the
orphaned, yeah. There's not, and it's the same way we deal with a server. Like if it just hasn't really changed, at least it's getting patched because we have an automated build process. The software is not being patched. Like they're not committing anymore, so they're not changing. Like if it's a WordPress site, it's not getting WordPress patches. But at least the underlying operating system is getting patches. There's not an easy way to identify which ones those are, really. Sort of the same way you would deal with the volume of
sprawl
servers.
could still be an issue in the future.
I think it could. I think because of the way we're starting to do storage and the fact that these are images, we can also just say, we'll keep the storage and we'll keep a copy of the image and turn off your service if we haven't heard from you in a year and a half. And if on the off chance that you complain, we can turn it on like that because the image and the data is right there. So it's not so much like we would with a VM where we destroy the VM and then we have to recover and get it back from backups and restore. Like we can just put the data, we can put the image into the cold storage and forget about it. That hasn't come up yet. So.
I'm just addressing that. That's a big reason for a lot of server sprawl. What actually happens is a lot of dead zombies that keep living even though they're not used or functional anymore.
Definitely, I would agree with you. I think that's going to be a problem as well. Hopefully, we'll get the kind of policy decisions we can to say, all right, nobody knows who this is, shut it off and see what happens. We'll see.
Sounds like you have not only continuous integration but continuous deployment.
Yeah.
What type of applications are those?
The majority of those are web applications. There are caching DNS servers that we use that way as well, because those are actually super simple for folks to work with, so they really don't care. I'd say other than 99% of it is web applications, Ruby on Rails or PHP stuff. No, some Node.js.
What kind of deployments do you guys do? Like Blue Green or?
That's another one of those. There are people who do that better than the boneheads that we are. We just haven't really written that bit yet. So it's, for the most part, it's kind of swap in and out. So there's, unless it's something that's load balanced and we roll through, it's a off real quick and turn back on. So it's not ideal, but hopefully we can work towards something. I think if we use something like OpenShift for orchestration, we're definitely going to take advantage of that. And one of our long-term goals is no matter what the container is, there's going to be persistent storage and network share or network storage, and there's going to be load balancing in front of it. Even if there's only really ever one set of containers, we're going to have it behind a load balance configuration so that we can mount the shares, bring it up, send the traffic that way, and shut it down. We just haven't gotten there yet.
Do you have remote developers?
We have one remote developer in Minnesota.
Because I'm collaborating with some guys in Australia.
Yeah.
And so you say, oh, we do development on our laptop, but if all my Docker pools and everything comes all the way down the wire from Australia, so I'm sort of lobbying for a jump host inside the data center in Australia.
Yeah.
Have you dealt with that issue, or you're only your one guy and he doesn't complain?
She doesn't really complain. It's not a big deal. She's able to build I mean, so the beauty of being able to do it is she can get the stuff and build it on her laptop too. So she doesn't have to pull or push. She's really just committing her code.
But she pulls from public repos to develop and then pulls from your repos to commit, or?
No, she's pulling. She's got the access to the Docker files that build these images, and she builds them herself.
And then layering,
there is a public base image like
layering
CentOS.
takes care of most of it, so it's mostly
Yep. Yeah. So there's really very little actual like back and forth. It's just literally just her code to the Git repo really.
Yeah.
She does pull some stuff, but it's not a huge deal really.
Well, obviously, let me add something to that.
Yeah.
Another way to solve that too is even with Docker distribution, which the package for the registry. If you actually throw an Nginx host in front of it, you can set it up to where and replicate your data. You can actually set up a master slave type thing to where you can actually replicate your data out across the world, spin up read-only instances there so that people can pull images quick. Their pushes are still going to be slow because you need to go through the one point.
Yeah.
But it's another way if people still want to develop on their laptop but have it distributed. It's a pretty easy way to do it.
Or use something like Artifactory, which has that auto-replication, multi-replication. So you could actually push each node and it'll get to all nodes eventually.
And we actually do push to 2 different registries, so we could do something like that. But right now we're just pushing to 2 different registries and 2 different data centers. I think you had your hand up in the back.
Or if you select Singularity.
Singularity is another like image format. It can use Docker files to build images and then export into the Singularity engine or whatever. We're using Singularity to, specifically it was to allow developers to run containers without root access. From what I understand, you can do that with Docker now. At the time, it wasn't really a thing.
There's a daemon set on the box like Docker does.
I'm not the one that works specifically on that. I don't think it's actually a daemon. I think it just kind of kicks off the process in their user space. And you,
Yeah, you all use dates here in the German area, is that right?
Yeah.
Okay, I was gonna ask that because you said about persistence for just 10 fast.
Yeah.
That your activated first, so you gotta worry about how to do that.
right. And we're not really dealing with that. We have 2 data centers that are like a street away from each other, and then we've got one in Raleigh, and that's all. We've actually got one in Singapore, but it's not really. That's not the same kind of thing. Like we wouldn't be trying to replicate NFS across from Singapore either. So okay. And then you had a question?
How much variability have you seen or do you anticipate in the Jupyter Notebook configurations? Like you're going to have some people doing a data hackathon and they want they want to add these types of libraries into the namespace.
Mm-hmm.
Is there much variability in your request for Docker images to support little one-off weekend projects and that kind of stuff, or is it all just to support MOOCs?
So that's actually this is actually a really cool thing, right? I think we originally did the Jupyter notebooks for the MOOCs, and then professors were asking about how to get extra packages and libraries, and we showed them how images are built. We gave them our Docker file, and we showed them how continuous integration works, and they just started doing it themselves. Wow! So it's really cool. Like they build their own images, they run their own tests, and they push them and use them. It's great.
That's kind of where source image is going to be kind of a cool thing too. Is you create a source image builder image for, say, Jupyter notebooks that, given a standard Jupyter notebook with the packages and ways of saying what Python packages it wants, it automatically builds a new instance of an image for that Jupyter notebook with all those packages installed. So it's kind of a factory.
We sort of reinvented that wheel too with our web hosting stuff. The Ruby on Rails applications are all deployed from a single Rails image, but their stuff, they commit a code and that's slurped into a build process that uses that image and shoves their code into it. And based on some extra special files in a dot directory that they include, can install extra yum packages or install extra gems or run things before or after. And they end up with an image that they didn't build. It was built entirely by us. They never touched a Docker file. They don't know what a Docker file is. They just gave us some code and a list of packages in a file.
Just a quick question. With the continuous integration you talked about with the developers testing on their own,
yeah, and
then you retest before it goes in production.
Yeah.
Have you standardized, or are you kind of? I've seen a lot of developers kind of using their own tools, or like I don't know if you guys.
Depends on the level of testing we're talking about. A lot of the testing we're doing is testing of the containers itself. It's not necessarily unit testing of the code. The developers that are doing a bunch of unit testing of the code also do it in containers with Docker Compose. They just spin up their containers with an environment variable set of testing and run through their tests that way. And then when they go to commit their code, because it's passed its unit test, it spins up and runs through the environment tests and either pushes or will commit or not commit the code based on whether it passes those tests. Those tests are standardized inside the containers, and they can add more if they're building their own images. If they're not building their own images, it's going to run through just to make sure the environment is the way that we made it for them. Any other questions, comments? I think I had like maybe one other slide. Oh, no, that was the last one. All right, cool. My name is Chris Collins. These are the ways you can get in touch with me. I love talking about this kind of stuff. I'd love to hear about orchestration or containers or cool things you're doing. And if you have any questions or anything, I'm happy to talk. Thank you very much.
Yeah, so that's it. I'll be finding if anyone wants to speak next month, kind of like on the wire here, or knows anyone that would love to speak. You can message me through Meetup. My email's on there as well. And then Chris said he's going to be available till midnight-ish, so one-on-one talk with him. Take as much time as you want. He does charge $150 an hour, he said, I think, something like that. So
Is the Hangout going to be available offline?
it is. I think AV Master in the back recorded it all. Yes, so it will be available. He's going to throw it up on Dropbox. We'll get the link on the Meetup page.
So this isn't on YouTube?
No.
In a Google, isn't a Google Hangout?
No, it was a Zoom meeting. Yeah. So, but it was all recorded, so it'll be available. Awesome. Thanks, guys.
Thanks.
All right.